Okay, we learned a lot of antiderivative rules and formulas, so I just want to spend some time practicing. So I've got two problems up here on the board that use mostly the formulas and rules that we've talked about. You'll notice I did introduce one hyperbolic trig function here, but I think you should be able to figure that one out. So what I would like to encourage you to do is pause the video right now and try to work out these two problems. Once you've done that, turn the video back on and we'll work through them together. Welcome back. Okay, so if I want to work through this first one, the first thing I'm going to do is just rewrite things. So I'm not ready to do the integral yet, so I'm still going to have the integral sign and the dx, but I'm going to just rewrite this. This is 3 times 1 over x. Now remember, that's the one power that I don't want to rewrite as a power. So I'm not going to write that as x to the negative 1, because that's the exception to the power rule. But by just sort of separating out the 3, I can see it's going to be the constant multiple rule, and then I need to integrate this reciprocal function. Okay. Minus 4, this is going to be x to the negative 2/3. So a negative exponent because it's on the bottom. The thirds is because it's a cube root here, and the power of x that we're taking is that we're squaring, so that goes on the top of the fraction. Plus 5 minus 3 times e to the x plus 2 times secant squared x. These last few pieces didn't really need to be rewritten. Okay. So now I'm just going to work my way across. I'm going to write down an antiderivative of each of these pieces, and then I'll write that plus c at the end. Some of you may want to get in the habit of writing the plus c first. If you find that you're often forgetting it, I would suggest that you get in the habit of just writing it first. It's frustrating when you do all the work to get the right function and you leave off the plus c, and it seems like just a piddly detail, but it's actually really important, because this problem doesn't have just one answer. It has infinitely many answers. And we will see sometimes where that c actually becomes really incredibly important. Okay. All right, so let's see. This is going to give me 3 copies of the natural log. Let's hope you remembered the absolute value of x, because remember, in this function, x would be allowed to be negative, so I need to make sure it's allowed to be negative in my antiderivative as well. Okay. Minus 4 copies of negative 2/3 plus 3/3 would become x to the 1/3. Divided by 1/3 is times the reciprocal, so that's going to become 4 times 3. That'll be a 12 in a minute. Okay. Plus 5, that's a constant. The sorts of functions that have a constant derivative are lines, which have a constant slope. So that's 5x. Minus 3 times an antiderivative of e to the x would just be e to the x. Plus 2, and then I recognize that secant squared is the derivative of tangent, so tangent of x would be an antiderivative of that. Okay. Now, ordinarily, I would just go to my next line to simplify things. I haven't left myself quite enough space, so I'm just going to come back here and say 4 times 3, well, that's 12. Okay, and everything else was pretty nicely simplified. So here's my answer to the first one. Okay. So now let's work out this second one. Again, I'm going to go through and just rewrite any pieces where rewriting it's going to make it easier for me to take an antiderivative. So here I notice that my x's are on the bottom, so I'm going to rewrite that as a negative power. That's 5/2 x to the negative 3. Notice the 5 and the 2, that fraction 5/2, that's the coefficient. The 2 is on the bottom as well, but it's not taken to the negative 3rd power. So I really need to just deal with that as being part of the constant. Okay. Then minus 3 cosine x plus 5 times 2 to the x. Notice here I cannot multiply the 5 and the 2 because order of operations says I would exponentiate before I would multiply. So 5 is my constant coefficient, and then 2 to the x is the function I will integrate. And then minus 2 cosh of x. So really the only piece we needed to rewrite was this one right here. So now I'm going to get 5/2 times Negative 3 plus 1 is going to be negative 2. So that's going to be x to the negative 2. Divide by that new power. So that's multiplying by a negative 1/2. Minus 3 copies of an antiderivative of cosine. So I know it's either sine or negative sine. Let's see. If I start with sine and I take the derivative, I get cosine. That's what I want. Okay. Plus 5 times an antiderivative of 2 to the x. So when it's an exponential function, I always get the exponential function back. But if the base isn't e, I get an extra factor. And when I'm integrating, it's the reciprocal of the natural log of the base. Okay. Minus 2 times I need an antiderivative of cosh. Now, we haven't talked about the inverse hyperbolics, but I recognize cosh is the derivative of sinh. So an antiderivative of cosh would be sinh x and then plus c. Now this time I didn't write the plus c first, but I remembered to do it at the end. Again, if you think you're likely to forget, you might make that your first step. Okay. And then I would just go back and simplify these things. I think what I'll do is erase this top function to give myself some more room to do that. Okay, so this is going to be negative 5/4 x to the negative 2. If you prefer to write that as x squared in the denominator, that's totally fine. Okay. Minus 3 sine x plus 5 over ln of 2 times 2 to the x minus 2 sinh x plus c. Okay, excellent. What I'm going to suggest you do before the next video is let's look at this hyperbolic trig stuff. There are 6 hyperbolic trig functions. We're not going to know how to integrate each and every one of them. But what I want you to do is write down the 6 derivative formulas that we know, and then write the corresponding integration formulas. So for example, with regular trig, we said the derivative of tangent of x was equal to secant squared x. That was the derivative formula. The corresponding integration formula was that the integral or antiderivative of secant squared x was equal to tangent of x plus c. Okay, so do that with the 6 hyperbolic trig functions, and we'll review those together at the start of the next video. Just one quick reminder, some of you may be developing the bad habit of not writing that dx. Break that habit now. That's going to start hurting you in the future if you don't get in the habit of writing it. It is an important part of the notation here.